So we left off looking at missing mass questions, Nick. Just to give you a quick reminder, we called this thing an Atwood machine. We had to add some mathematical restrictions. We said this pulley had no mass or no friction, because if it had mass, it would actually have its own inertia. It would add another force to the equation. Yeah, we're not going to ignore that. If it had friction, same idea. These ropes have no mass because otherwise the mg on either side would be changing depending on if you had more rope or less rope. We're pretending all of that isn't happening. Having said all that, we said this was a nice idea of a many body problem. Typically, we had a tug of war between the two mg's. And what I said to you, Ashley, is I'm going to give you one of these on your test. We said, actually, this is a fairly multi-step question. I think when we counted it up, we said you're doing actually 6 or 7 steps. Oh, I'm going to make this probably worth 5 marks, 6 marks, or 7 marks, just because I want to give 1 mark per step. I can't call it free marks, but hopefully I can call it guaranteed marks, because there's going to be one of these on your test. We said the tug of war was between M1G and M2G, which one was heavier. We said we wrote an equation for everything to find the acceleration for everything, and then to find an individual force, we used an individual mass. Which one didn't really matter. You okay with that, Callie? Then, what's different about this one? What are they asking us to find? Okay, this is a missing mass question. Now, for you to solve a missing mass question, I either have to give you acceleration or tension. Which one did I give you in this question? Tension. And I have to tell you which way we're accelerating. If I don't, it's not solvable. But I did give you both of those pieces of information. Instead of writing an equation for everything, we're going to, because I'd have M all, I don't know one of the masses, I'm going to write an equation for the mass that I know. This is going to be our strategy. Later on, if you remind me, we'll kind of write this down, but we're just going to do one right now. Brandon, which mass do I know? M1. This is a job for a free body diagram. What are the forces acting on M1? Get the obvious one. Gravity. Yep, what else? Tension. Okay, you okay with that? Hopefully that's not a big surprise. I'm going to write an equation just for mass 1. First of all, which way is mass 1 accelerating? The question had to tell me. Otherwise, you can't solve it. It's upwards? Who's winning? First of all, M1 and M2 are not forces. Those are bad guesses. Of the forces that I've put on my free body diagram, of which there are only 2, who's winning? Tension. Who's losing? Don't say M1. Can you please read the thing that's... Ah, boy. That's like pulling teeth from you people. We've labeled it. Yeah, my equation here, because M1 is accelerating up. Tension minus M1G. What's that going to equal? Not M all. M1. Now, why do I start there? For me to find the missing mass, I need tension and acceleration. They only gave me tension, but ooh, look, from this, I can also find acceleration. Or, if I gave you the acceleration, you could find the tension. You need both to find the mystery mass. Brandon, how would I get the A by itself?
You divide everything by M.
By M1. Thank you. I get, well, you know what? I think I'm plugging numbers already. 56.5 minus 3.2 times 9.8 divided by 3.2. What's A? Bracket 56.5 minus 3.2 times 9.8, close bracket, divided by 3.2. I'm going to write that, but is this what they wanted me to find? You know what? I'm going to use my answer button for what's remaining. But so 7.856. Since this is my final answer, I could really write the whole thing. I don't care how many sig figs. I'm going to go 7.856. Not even bothering putting a box around. That's not what they wanted me to find. Read, what did they want me to find? Thank you. We're going to now do a free body diagram for mass 2. What are the forces acting on mass 2? Get the obvious one. M2G. What else? Tension. We're now going to write an equation just for mass 2. Who's winning? Mass 2 is not a force. Please read me something from the free body diagram. Who's winning? M2G could be winning. Who's losing? What's that going to equal? M2A. We're just writing an equation for mass 2. Read, what are they asking me to find? How many M2s do I have in this equation? How many would I prefer? You know what? Let's get all the M2s to the same side. I'm going to swappy dance. I'm going to plus tension over here. I'm going to minus M2 here. Why? I don't know. May as well do that. Read, how many M2s do I have? How many would I prefer? You know, it'd be really neat. It would be really neat if there was a Math 9 operation that I could pull out of my back pocket from Math 9 and change this from 2 M2s into 1 M2. There is. And if anybody can tell me, there's a candy in it for them. Eric? Nope. Math 9. Is there an M2 in everything? Yes? Well, in the same way, don't write this down, that in grade 9 you learned if you have 5x squared plus 3x equals 7, you can write that as x bracket 5x plus 3. You learned you can factor things out if they appear in everything? Well, is there an M2 in everything? Then, Lena, I can write this as if you're not sure, multiply it back in to see if you get the previous line. You do. Read, how many M2s are there now? Woohoo! How will I get the M2 by itself? What's the bracket doing to the M2? So, really? I can figure that out without having seen it? Well done. Who's in grade 12 here? Who's in pre-calc 12 this semester? That there is, you would have been hugely useful if you didn't know that trick for when you're doing logs. Don't write this down. But when you have this, and you're solving for x, how would you get the x by itself? Divide by the bracket and you're done. No need to decimalize, no need to, you can type it all in and get an answer. You learned that, did you not? Absolutely that way. You can type that in. Don't have to do decimal. Is that when you were taught? Okay, I got to talk to the math teachers. Way better. So, I've scrolled down. What was tension? That's why you need both tension and acceleration to find the missing mass. All over 9.8, what was A? But I'm going to use my answer button there because I think that was a rounded off value, yes? Hey, I don't need brackets around the top. I do need brackets around the bottom. 29.06, I'll call it 29.1 kilograms. Did I say I like this question? I like this question. If I didn't, I should say I like this question. I like this question. I like this question. This is a bit of an advanced question. We're reversing what we've done. Instead of saying, here's both masses, find A, find T, I'm telling you if I give you one mass and one of acceleration or tension, oh, and which way we're accelerating, you can reverse engineer the rest of the system. If you have room at the bottom, if you want to make a little list, it's going to be something like this. Right? You know what, Mr. Duick? Let's type it because your handwriting is so atrocious. Write equation for mass that we know. Find A or T. You'll have the other one, but you need both. And then write equation for mystery mass. Use GCF to get one mass if necessary. Once in a while, you'll have a situation where when you write your equation for the mystery mass, you only have one M2. Well, okay, then you're good. Don't bother writing an equation for M all. You don't have to write that down if you don't want to, but it won't work because when you write an equation for M all, you'll be missing a mass and you'll either be missing a tension or an acceleration, and you're out of luck. I'll put this back up if you need it later. Let's do example 6. Given that M2 is 4.3 kilograms and accelerating downwards at 2.5 meters per second squared. A says, boom, boom, find the tension. B says find M1. Again, I think this is a missing mass question. So am I going to start out by going winner minus loser equals M all A? Nope. Okay. Gershine, which mass do I know? Let's write a free body diagram for mass 2. What are the forces acting on mass 2? Get the obvious one. Good. What else? Okay. Let's write an equation for the mass that we know, M2. Who's winning? They had to tell me the direction of acceleration. Oh, because it's accelerating downwards. In fact, you could even, if you didn't want to forget, you could even do that if you wanted to. Yeah. Okay, so for part A, M2, keep going. Keep going. What did they want me to find in part A? Okay. In the previous one, I gave you tension. We found A. Here, I'm giving you A. We can find tension. Sloppy dance in this case. We'll get M2G minus M2A. That equals tension. We'll get M2 4.3, G 9.8, minus 4.3 times 2.5. And I end up with 31.39. Need someone to double check me. Yeah. Okay. By the way, how many steps did we have to do to get an answer? I think 3-ish. I'd probably make this worth 3 marks, maybe. Okay. And what's B want me to find? What should I do? Sorry? Before I even do an equation. How would I get the equation? Yeah, okay. What are the forces acting on M1, Ange? Get the obvious one. What else? Have I, by the way, convinced you of the usefulness of free body diagrams and Newton's laws? You might remember when I taught you free body diagrams, I said to you, this is the tool that you're going to use all the time. I can't emphasize how handy it is. But can you try and do these all in your head? I mean, Nick, maybe, but the 1 second it takes to quickly do the free body diagram, I think is so worth it. Ange, what's my equation? How do I know tension's winning? Because it says that M2 is accelerating down, so M1 must be accelerating. So the winning direction must be, same answer, up. So which force is pointing up? Tension. Ange, how many M1s do I have? How many would I prefer? This isn't going to be a swappy dance. I'm going to plus the M1G over and get them all to the same side. So I'm going to get this. Tension equals M1A plus M1G. How many M1s do I have? How many would I prefer? You know, it'd be really cool if there was a Math 9 operation that I could pull out of my back pocket and change this from 2 M1s into 1 M1. Is there? Really? Wow, that is so cool. You mean that math is actually useful? I mean, geez. So you're telling me it's going to be, and then M1A plus G? Okay. I'm trying to find M1. How would I get the M1 by itself? How will I move the bracket up? What's the bracket doing to the M1? So? Really? You're telling me M1 is going to be T divided by A plus G? It's going to be 31.39 divided by 2.5 plus 9.8? If you're looking for a pattern, sometimes it'll be tension over G minus A. Sometimes it'll be tension over G plus A. I've never bothered trying to memorize which pattern is which. It's just easier for me to derive it and solve it. But if you get that, you've probably done this correctly. Answer button, haha, divided by 2.5 plus 9.8. I got 2.55, 2.55? It's a mass. Did I put kilograms on the previous one? I did. So I thought for a minute I put weird units on. That's missing mass questions. So what's your homework? You can certainly try number 1. That's a regular Atwood machine. Number 2 is a regular Atwood machine. Turn the page. Number 3 is good. Okay. Try number 4. I haven't done one like number 4. Number 4, I have not given you M1 or M2, but I've given you acceleration and tension. Write an equation for each individual mass. Think which way is it accelerating. If it's accelerating up, tension is winning. If it's accelerating down, mg is winning. And get the individual mass by itself. I haven't done one like that. Okay? You can skip 5 and 6. 7 is good. That's a missing mass question. 8 is good. That's a missing mass question. 9 is good. And you may notice if you look at number 9, that's actually from a June 2004 Physics 12 provincial exam. Yes, I'm doing some Physics 12 with you. Live with it. And we're going to kind of pause there because I also know a whole bunch of you are working on some of the homework. And I also know somebody asked me to go over one of the questions from one of the homework. And I will in just from the homework in just a second.